In this presentation, we will learn how to insert a new node at the end of the circular doubly linked list. So let's get started. Let us suppose we have this circular doubly linked list and tail pointer is pointing to the last node of this list. Now, our target is to insert this new node at the end of this list. Okay. For this purpose, first we have to have a temp pointer which must point to the first node of this list. After this, we need these 5 lines of code. New p next equal to temp, new p prev equal to tail next equal to new p, temp prev equal to new p, and tail equal to new p. Now let's just try to understand this procedure one by one. First we will understand this line of code, that is new p next equal to temp. Here we just want to update the next part of this node so that it can point to the first node of this list. Now let me tell you why. Because here you can see in this list, this is a circular doubly linked list, right? Here the last node is also pointing to the first node of this list. That is why it is important to update the next part of this node so that it can point to the first node, because this is going to be the new last node of this list. So let's just update the next part of this node. You can see that now it is pointing to the first node of the list. After this, we have this line of code, that is new p prev equal to tail. That means we have to update the prev part of this node so that it can point to this node, right? After this, we have to update the next part of this last node so that it can point to this node. That is why I have written tail next equal to new p. After this, we have to update the prev part of this node, not this node, okay? We have to update the prev part of the first node so that it can point to the new node, and that's what we want at the end. That's why I have written this line, that is temp prev equal to new p. And after this, we just need to update the tail pointer so that it can point to this node. And that's it. That's all what we need. This is the resultant linked list so obtained, right? And obviously the time complexity is big O of 1. There is no loop involved in adding a new node at the end of the list. That is why the time complexity is big O of 1. Now let me just show the complete code in code blocks. You can see the complete code available over here. We have struct node, then we have add to empty function, add at beg function, which we have already seen in the previous lectures. Then we have add at end function. This is the function we need to focus, right? Here to this function, we are passing the tail pointer as well as the data we want to insert in the new node, right? After this, you can see that I have declared a new p pointer and I want to create a new node with the help of add to empty function, okay? That is why I'm calling add to empty function, and to this I'm passing the data. After this, I'm just checking this condition. If tail is equal to null, then simply return new p. If there is no node in the list, then simply return new p. That means simply return the new node, right? Else we will continue with this procedure. That is, first we have to declare a temp pointer which must point to the first node. Then we have to update the next part of the new node, prev part of the new node. We have to update the next part of the last node, and we have to update the prev part of the first node, right? And then we must update the tail pointer so that it can point to the new node, right? Finally, we just have to return the tail. That's it. And you can see in the main function, I have declared a tail pointer and it must be initialized with null. After this, we should call add to empty function, and to this function, we are passing this data 45. This is important to create the first node of this list. And actually, the first node contains this element 45, right? Then after this, add at beg function has been called, and this helps us in adding a new node at the beginning of the list. Currently there is just one element, so 34 is added in the beginning, which means the list consists of 2 elements, 34 and 45. After this, add at end function has been called, which is used to add the data at the end of the list. So after this, we know that the list must look like 34, 45 and 56. Then you can see that I'm calling print function to print all the elements of the list. Now let me just execute this code. You can see over here, this is the resultant linked list so obtained, that is 34, 45 and 56. Okay friends, this is it for now. Thank you for watching this presentation.